All right. Hello, hello. I hope you all had an excellent day off. I am here recording videos while you all are sitting at home, probably sleeping, eating all your mama and daddy's food and all that good old stuff. So, we are starting congruent triangles. So, you will learn how to prove triangles are congruent by five ways or postulates. Now, I gave you the notes for this, so you're going to need to copy and follow along from the notes. You will need to draw some pictures in there as well. And then from there, you will staple this into your notebook, okay? So, the first thing, oh, I messed up. The first thing, congruent triangles have three congruent sides and three congruent angles. And I'm going to pause the video real quick because I'm going to need to calibrate the board. So give me 1 second. Matter of fact, I'm not going to pause it. Y'all just going to see the calibration. All right. So without having to show all, you can prove these triangles without showing all the corresponding parts, which y'all learned in last video. Remember, when naming congruent polygons, order counts. Corresponding parts must match, okay? So we are going to first talk about the 5 ways you can prove triangles are congruent. The first way is the side, side, side postulate. That means if three sides of one triangle, ooh, what happened there? Three sides, trying to see why it's not working up here. All right, that's supposed to say sides of one triangle are congruent to three sides of another triangle, then the two, why is it so far down? I'm even having issues at school. Let's see if I move this down, what would happen? Hold on, y'all. I'm having issues. Let's try it there. All right. We are going to try to redo this one more time, recalibrate one more time, and then we're going to go from there. All right. So, if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. Okay? So here is a picture. Oops. It's supposed to be in. And then we have two triangles, FXA. So XAF is congruent to triangle what? If you notice, three sides of one triangle is congruent to the three sides of the other triangle. So if you look at this, it says XAF. So if I start at X, I'm in between the 1 mark and the 2 mark triangle. 2 mark sides. Is everybody with me? X is in between the 3 marks and the 2 congruent marks. So the one that's in between the 3 and the 2 on the other side is M. And then it says XAF. So you're going to go X through the 2 through the 1. So let's do it again. M, if I'm going through the 2, I have to go to N to 1 is O. So it should be M, N, O. Now let's look at all the congruent sides, corresponding parts. FX is congruent to MO because they both have 3 marks. AX is congruent to MN because they both have 2 marks, congruent marks. And NO is congruent to AF or FA because they both have 1 mark. Okay? So the first one is side, side, side. The next one is side, angle, side. If you notice, we also say SAS. If you notice, the angle is in between the 2 congruent sides. Okay? So, if 2 sides, oh, it's messing up, and the included angle of one triangle is congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. Let's look at this picture. We're going to draw a triangle FAX, and we're going to mark it as such. And then we're going to draw the triangle MNO, and we're going to draw it as such. If you notice, I have 2 congruent sides, and we have an angle in between the 2 congruent sides. Okay? So, XA is congruent to MN. Angle N is congruent to angle A, and NO is congruent to FA or AF, whichever one you want to say. So therefore, XAF, XA, so I'm going to go from no markings to 2. So the other one, FAX, if you do the corresponding sides of the other triangle, it's going to be MNO by side, angle, side. So we have side, 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 angle, side. Now, let's try an example here. OXB is congruent to what? If you look at it and it corresponds, OXB is congruent to RXM. And now let's name our corresponding parts. OX is congruent to RX, right? Then you have MX is congruent to BX. And this line right here should have went under this RX, so please excuse it. And then you have angle. You can't say X and X. You have to use 3 points. OXB is congruent to RXM because they are vertical angles. All right. So therefore, let's go back. If you look at this, they are congruent by side, angle, side. Side, angle, side. All right. The third way is angle, side, angle. So if 2 angles and an included side of one triangle is congruent to 2 angles and an included side of another triangle, then the two triangles are congruent. Let's look at it. We're going to have this first triangle, X, M, S, C, O, T. Now, angle X is congruent, if you look at this picture, it's congruent to angle O. OT is congruent to SF. And angle S is congruent to angle T. I'm going to put a congruent sign. So therefore, COT is congruent to MXS by angle, side, angle. If you look at it, you have two angles marked and one side marked. You have to determine if the side in between the two angles or not in between the two angles. And it is in between the two angles. That's why it's angle, side, angle. Now, the fourth way, there are 5 ways, we're on number 4, is angle, angle, side. So it is when you have two angles. Now here's the difference. And a non-included side. Are congruent to two angles in a non-included side of another triangle, then the triangles are congruent. So, let me give you a picture. X, S, M. And we're going to call this one R, D, B. So, can we conclude that these are angle, angle, side? Well, first of all, angle X is congruent to angle B. Angle D is congruent to angle M. And RD is congruent to MS, or SM. Therefore, triangle RDB is congruent to triangle SMX by angle, angle, side. Do you see that the angle, the side is not in between the two angles? If it was in between the two angles, it would be right here. Okay? It is not in between the two angles. Now, the last one is hypotenuse leg. Now, here's the thing about hypotenuse leg. It only works for right triangles. And I will show you how to know this one in a minute. So, if the hypotenuse and the leg, the hypotenuse of, and a leg of one right triangle is congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent. So, remember, the hypotenuse is the side across from the right angle. T, A, C. And then here's the other triangle. Now, angle A is equal to 90 degrees, right? And angle O is equal to 90 because they're both right angles. If they're both 90, that means that they are congruent to each other. TC is congruent to DG. And those are your hypotenuse, because they are across from the right angle. Okay? AC is congruent to DO. So therefore, TAC is congruent to GOD by hypotenuse length. Okay? Now, there are some other markings unless there are vertical angles, angle pairs from parallel lines, or shared side. You may not mark any other markings on the diagram so that you can prove the triangles are congruent. Now, we have talked about a couple ways. We talked about side, 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 angle, 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 side, and HL. Now, there's a couple that we did not prove, okay? And one of them is angle, 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 all right? You cannot prove triangles just because their angles are the same does not mean their sides are the same. So if you have something like this, all right? Whoops, and I put the picture in the wrong spot, so we're just going to move this. All right? If you have 3 congruent angles of one triangle equal to 3 congruent angles of another triangle, that does not prove that they are congruent. I call this no roadside assistant, no AAA, okay? The other way that you can prove that they're not congruent is if you have side-side angle or angle side-side. And what would be the abbreviation for angle side-side? Some of y'all are probably laughing right now. So, we don't curse in geometry, we don't curse in Ms. Nash's class, so we're not going to have no angle side-sides in here, okay? Now, when you get an angle side-side, you need to start going ding, 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 ding. Remember how I told you there was going to be one way that you were going to be able to determine if it was hypotenuse leg? If you get an angle side-side, you need to say to yourself, self, is it a right triangle? And if your answer is yes, then you can prove it by hypotenuse leg, because hypotenuse leg is really an angle side-side. If your answer is no, then they are not congruent, okay? And the last way is if their markings don't match. Give you an example. Do you notice in the first triangle that I created right here, the angle is in between the two sides. In the second triangle, the angle that I marked is not in between the two sides. That would also prove that they are not congruent. Okay? Now, there are a few things that you have to put in pictures always. The first one is called shared side. If the two triangles share a side, this is called the reflexive property. Okay? You are going to need to remember that those sides are congruent to themselves. So if you look at this, here is one triangle. Whoops, my thing is off. And then here's another triangle. Whoops, ooh, you're really off. Do you notice they share that side in the middle? So we call that a shared side. It is congruent to both triangles. Over here, the two triangles share the side at the bottom. For this triangle right here, they are congruent by side, side, side. Now, if you look here, I have an angle, and a side on both of them. So this won't be congruent by angle, angle, side. Okay? Next one is you must mark any vertical angles. So vertical angles are congruent. These are markings that you have to mark every time. They're not going to be given to you. So that means this angle is congruent to this angle. Therefore, these triangles are congruent by what? Well, let's look at it. If you look at the first one, and I'm talking about this triangle right here, I have two angles and a side. Let's see if it's right for this triangle. I have two angles and a side. Is everybody with me? So I have two angles and I have a side. Now, here's the question. Is my side, because the two angles are the same, is my side in between the two angles? Which means, is the side in between the two angles? No. The side is not in between the two angles marked. So my way of proving this is by angle, angle, side. Okay. The next one is vertical angles. They will not be marked as well. You must not forget the pesky alternate interior angles. Alternate interior angles. Well, Ms. Nash, I don't know how to do my alternate interior. I look at it as a Z. It's the two angles inside the Z. First of all, my parallel lines are the two lines marked by an arrow. So I'm going to have two sets of Z's. Here's my first Z. Does everybody see that? It's on its side. The angles that are in the Z are right here and right here. Now, there's another way I could draw this Z. Let's look at it. Could I have went this way? Yes. So that means this angle is congruent to this angle. Now, if you look at that, on each triangle, I have an angle, angle, and a side. Is my side in between the two angles? No. So this is also angle, angle, side. Now, some of y'all might say, well, I could have put vertical angles there. You could have. And that's what we're going to get to next. Sometimes it could be a bunch of different things. If you notice, I have a shared side here. Then I also have parallel lines. Here's my Z because these two lines are parallel. So I can mark. Or I also have these two lines parallel. So this is also a mark. So this time I have two angles and I have a side. Now, is my side in between the two angles that are marked? And my answer is yes. So, this is proven by angle, side, angle. All right, now, we're going to practice some of these problems. And then you have a few to do on your own. I need you to turn to the sheet that you have that looks like this at the top. All right? We're going to do these 5 problems together. So, remember the 5 ways are side, 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 angle, side, angle, side, angle, 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 side, and HL. So, first thing you need to tell yourself is, what do I have marked? I have 3 sides of one triangle marked and 3 sides of another triangle marked. This one, just by looking at it, is side, side, side. So now let's go ahead and write a congruent statement. I can start anywhere. I'm going to start with triangle ABC. Now I have to make sure I follow the same pattern for the next triangle. A is in between the 1 and the 2 mark. So the angle that's in between the 1 mark and the 2 mark is F. So I went A, B, C. A to B, I went through the 1 mark. So I need to do F, E, D. And there's your answer. Now, on this one, I have an angle, I have an angle, and I have a side. Is everybody with me? So I have to take the one that is not like the other, which is this side. Is this side in between the two angles marked or not in between the two angles marked? It's in between. So I'm going to put in between. And there's my answer. Angle, side, angle. So if I want to use triangle ABC again, I can do this one a couple ways. I do need to start at Y. I could say YXZ, or I could say YZX, since they're both the same angle. They have the same markings. All right, number 3. I have to input something in here. I have a shared side. Do you see that? So I need to mark it. So once I mark that, if you notice, I have a side, I have another side, and I have an angle here. I have two sides. I have to see where this angle goes. Is this angle in between my two sides that are marked? And it is. So it is congruent by side, angle, side. So triangle FGE is congruent by triangle HEG. All right. Number 4, I have a shared side. Now, I have an angle, and I have a side, and I have a side. Now, whoops, they didn't break up. Let's see if I can break them up. There we go. All right. Let me fix this together. All right. So I have two sides, and I have an angle. My question to you is my angle in between my two sides? And my answer would be no. So I'm going to get this. Ding, 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 ding. We don't have any angle side sides in this class. Is this a right angle? And the answer is yes. So therefore, this is not ASS. It becomes HL. Now, not all right angles are HL, but HL can only be done with a right angle. So this becomes triangle ABC is congruent to triangle CDA. And the last one. It looks like I have an angle, another angle, and a side. Now, is my side in between my two angles? No. So here is my answer. Angle, angle, side. And if I write my statement, ABC is congruent to triangle EDC. All right. So you are to do this on a separate piece of paper. Do not rip it out of your notebook you use notes for. If you have it on there, I'm going to count it as a 0. You need to draw these three pictures and tell me how are these three triangles congruent. Okay? And then we'll discuss more when you get into class.